Hello, class, and welcome to lesson 5.4, geometric distribution. Now, last day, we took a look at a different type of distribution, and that dealt with failures and success, and that was binomial. So either it was failure or success. Today, we're going to take a look at a different type of distribution, and it's either listed as wait times, that's another one you're going to see, or geometric distribution. So when we take a look, we can determine the probabilities and expected values while focusing on wait times, which is geometric distribution. Okay, so basically we're going to look at if you have an emergency and you're sent to the hospital or you have to go to the hospital, how long do you have to wait? So how many fails occur before you have success, which means when you get chosen to see the doctor or to see the nurse. Okay, so it's a little different type of distribution, and I'll show you how the wording goes a little bit later. All right, so let's take a look at an example, and this will help us introduce this subject. Okay, so a researcher knows 30% of Huron County residents are smokers. Okay, if she calls 5 random numbers, not random phone numbers, okay, what is the probability she contacts a majority of smokers? So out of the 5, guys, it's either going to be 3 or 4 or what? Or 5, right? Okay, for majority. All right, let's think about our random variable. The random variable, what we're looking for is the number of smokers. Okay, and our success in this case is calling a smoker. Okay, which means our fail is calling a non-smoker, right? So it says that 30% of Huron County are smokers. So probability of success equals 0.3, 30%. Are we okay with that? So the opposite of that, which is your failure, that means Q equals 0.7. So this is going to be like your fail, okay? And this is like your success, right? Okay, cool. So what we need to do is we need to find the majority, so the probability has to be of X has to be greater than or equal to 3, right? Because 2 is not enough, but 3, 4, or 5 is. Okay, so to do that, we find the probability when X equals 3 plus the probability when X equals 4 plus the probability when X equals 5. Okay? Everybody okay with that? Now, how do we figure this out? Okay? All right. Well, we're going to have to show some rough work. Okay? And then we'll put our answer back in here. So we'll leave some room here, and we'll show rough work down here. Or if you have a side margin, you can do it too, but you might need the bottom part. So how do we figure out the rough work when probability equals 3? All right, well, when we call, how many are we calling total? We're calling 5, and we're choosing, in this case, we're choosing all 3 callers to be smokers, right? Okay, so that's going to be 0.3 raised to the 3, because there's 3 successes, meaning there's 3 smokers. Okay, and out of the 5 calls, there's 2 that are non-smokers. So you plug that in your calculator, folks, and you get 0.1323. Okay, that's one scenario. Now let's do another scenario that we need, probability when X equals 4. So out of the 5 calls, we choose 4 of them to be smokers. So that's 0.3 raised to the exponent 4. Okay, and 0.7 raised to the exponent 1. Okay, 0.0284. Okay, and the last option, I apologize, I forgot a bracket there. My last option is X equals 5, which means out of all 5 callers, all 5 are smokers, which means 0.3 is raised to exponent 5, and 0.1 is raised to exponent 0. We know when we're calculating that that equals 1 and that equals 1, so you're just calculating that out, right? Okay, and it's very, very small, 0.0024. Okay, so I'm going to take my answers 1, 2, and 3, and add them up in here. So I've got 0.1323 plus 0.0284 plus the last one, which is very, very small, 0.0024. Add them all together, and we get 0.1631. So therefore, if we change that to percent, therefore, there is a 16% chance that majority smoke. And I mean majority of the callers. Okay? All right. So that's one way to look at it, and that's using the binomial distribution. Let's take a look at the second question. What is the probability she finds the first smoker on the fourth call? That means the first call, is it a success or a failure? It's a failure. Second call, failure. Third call, failure. Fourth call is the first success. Okay, so let's take a look at this. So if I have my first call and my second call and my third call and my fourth call. Okay, so let's take a look at what happens here. Oh, sorry. Just wanted to extend that. There we go. Okay. So the first call, folks, is what we call, come on, computer, work with me, please. First call is a fail, okay, and which means to times it by. The second call is a what? Fail. Okay, and the third call is a fail because we didn't reach a smoker, and then the fourth call is where we had success. Okay, and I could keep going on to the fifth call, but we don't have to worry about the fifth call. We don't care about it because it's not part of the problem. Okay, so when we take a look at the probability of 3 fails, then success, and remember, and means to multiply, so this equals a failure on the first, which is Q, times, which means and, a fail on the second, and a fail on the third, and then we finally get our success, which is Q. Sorry, which is P, on the fourth call. So how many Q's do we have? We have Q to the power of 3 times P. Okay, now if we plug that in, we've got 0.7 to the exponent 3 times 1 of the successes. Okay, plug it in your calculator, guys. And you should have a 0.1029, which means, therefore, there is a 10% chance that the first smoker you talk to will be on your fourth call. Okay, so this is a different type of distribution. Notice it's the number of failures before success. Okay, all right, and it's a cool format. It's pretty easy. You just have to realize what you're looking for in the question. So let's take a look at the formula. Okay, so the probability in a geometric distribution is the probability of the first success. So when do you get the first success? Out of X failures. So here's the key. X is the number of failures before success. So in that last example, it would have been X equals 3 because there were success on 4, right? So success on fourth call, right? So therefore, X equals 3 because there's 3 failures first, right? As long as you can recognize it, that in the word problem, you'll be fine, okay? And geometric distribution is easier to calculate for both the expected value and the probability. So for the expected value, it's the number of fails before the first success divided by the success, okay? So this is also called the expected waiting time, okay? So whenever you see waiting time, you should relate that automatically to geometric distribution. So this formula is very simple, okay? All right, and we're going to take a look at this and relate it to the problem here. So it says for C, how many calls should she expect to make before reaching her first smoker? Okay. So my expectation of the finding the first smoker is my Q over my P, because it says expect, right? So note your expectation formula. So Q in this case is 0.7. divided by P, which is 0.3, and that gives you, if you plug it in your calculator, it gives you 2.3. And this is where you got to think about, what does this really mean? Okay, so the 2.3 means she's going to make 2.3 calls before reaching a smoker on the third trial, right? Because these are the number of failures first, right? Okay, so you basically have success on the third call. So therefore, she should expect to make 2.3 calls. I know you can't make 0.3 calls, so you could say 2 or 3 calls, okay, before reaching a smoker. So these are the number of failures, right? Because X represents the number of failures here. Number of fails before success. Okay, just make sure you throw that in there. All right, before reaching or reaches a smoker. Okay, and just put on here, folks, that would round down to 2, so we're going to say success on third call. That's what we would expect based on the probabilities. Okay? Awesome. Everybody okay with that? Awesome. Okay, so let's do one more example here. Okay, on average, and I know TV commercials drive me crazy. Some people PVR things so they don't have to watch it. But here, let's see. Take a look at this example. On average, TV commercials are on the air about 20% of the time. If you didn't realize that, that's pretty cool to note. That a third of the time, a third of a half an hour show is spent on commercials. Same with an hour show. Okay, so it takes you 5 seconds to determine if there's a commercial on before you change channels. Okay, so 5 seconds is an important thing to recognize here. So what is the probability that you will find something to watch in less than 3 changes? Okay, so what we have to realize that in this question, the X is what we're looking for, is the number of changes. Okay. And then our success, guys, is what? Hopefully you've found is finding a show, right? All right. So the opposite of, so probability of success, folks, finding a show. Remember, this is a failure, so that's 0.2. So probability of success is, actually, let's do failure first. So failure, let's make more sense, is finding a commercial. Okay. All right, so taking a look here, the probability of finding a failure, right, finding a commercial, as it says in the problem, Q equals 0.2, which is 20%, right? And then, so probability of finding a success is the opposite, or the complement to that, which is 80%, right? Okay, So we need to figure out the probability in less than 3 changes. So when we do this, we go probability where x is less than 3, okay, equals, so less than 3 means the probability when x equals 0, okay, plus the probability when x equals 1, plus the probability when x equals 2, okay, because less than 3 can't be equal to 3. Okay. Now you might be saying, hey, Miss R, what does this mean when x equals 0? Okay, just remember that x equals the number of fails in this case. Okay, how do I know? In the question, it'll say the word before. So, a commercial before you change channels. So what's the probability you will find something to watch? So the word before means how many changes until you find it. Okay? So x is the number of fails. So when you're talking about x equals 0, this means on the first try, that means there was no fails. So right away you found something to watch. Okay? If you're looking at when x equals 1, that's going to be on your second try. That you get success because the first try is a failure, so your second try is success, right? So it's the number of failures before success. And when x equals 2, this is really your third try. So you had 2 fails before you got success on your third. Okay, so let's figure this out. How do we do this? Okay, when we take a look at what x equals 0, okay, we're going to use our formula from above. So for each possible outcome, okay, it's going to be the failures raised to the exponent of the number of failures times the success. So when I take a look at when when x equals 0, that means we had no failures, okay, which means we had only success on the first try, right? Okay, plus, let's take a look on the second try. So on the second try, we had 1 failure first, and then we had success. Everybody okay with that? Okay. And then on the third try, that means we had 2 failures first before we had success. Okay? So plug that in your calculator, ladies and gentlemen. You can actually do it all together. I'm sorry, my finger slipped there. Okay, so plug it in at 0.992. Okay, so what does that mean? That means, therefore, there is a 99% chance that we find a show in less than 3 changes. Okay, that we find a show in less than 3 changes. Okay? So that's pretty good, folks. However, in reality, if I find a commercial on one show and I flip to another and I flip to another, I think some networks have the commercials on at all the same time, like the 10-minute mark in or whatever. So I find that interesting, but that's what the math tells us. Okay? All right, let's take a look at question B. How long should you expect to wait? Notice you see the wait time in there. So expect and wait tells you that we need an expectation formula, and the wait means geometric. Okay, so the Q is 0.2 over the P, which is 0.8, and that's your formula that will be given to you. Okay, and plug it in 0.25. Okay, now this is a tricky one. That means I will wait 0.25 changes. Okay. All right. Okay. And when you take a look at how long, we read in the question there that it takes 5 seconds to determine, right? So it's going to be 5 times 0.25, right, which equals 1.25 seconds. Okay? So, therefore, I will wait 1.25 seconds to find a show. So the tricky part about that was it told you the number of changes, but it didn't tell you the time. So I had to go back to the question up here where it says it takes you 5 seconds to determine if there's a commercial on. Okay? Awesome. Okay, so ladies and gentlemen, here is your homework. I'm not sure why it's written down twice. That's probably a little typo error. So here we go. Page 395, numbers 1, 2A, 4, 6, and 8. Have a great day and see me if you need any help. Have a great day.